in this video, we are going to do some more triangle proofs and specifically discuss the theorems side, 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 and side angle side. Okay, so in this first example here, we want to prove that triangle EFG is congruent to triangle HFG. Okay, so we want to prove that EFG is congruent to triangle HFG. Okay, so for the first statement, as you can see here, right, we have which segments are congruent to what. So EF is congruent to HF, okay, and that's given to us. So we are going to say that line segment EF is congruent to line segment HF. And that is because, and let's use a different color for this, it's given. Okay, so then in the next statement, we want to write the other line segment that is given to us. And we can see that clearly here, that this line segment, EG, is congruent to this line segment, HG. All right, and that's, again, given to us. So we're going to write that as well, that EG is congruent to line segment HG. And again, that is given. And so what else do we think is we can see as being clear that, you know, a line segment or a certain angle is congruent? Well, you can see that there's this line here that belongs to these two triangles. And so therefore that's a line segment. And we can say that because this line segment belongs to this triangle and this line segment belongs to this triangle, that it's congruent to one another because it's the same line segment that is going to each triangle. So the distance has to be the same. So we're going to say the line segment FG is congruent to line segment FG because of the reflexive property. And then that's enough information to prove how triangle EFG is congruent to triangle HFG, okay? Because clearly, so we can even put that here, clearly this triangle EFG is congruent to this triangle HFG by the side, side, side theorem. Okay, so triangle EFG is congruent to triangle HFG by side, side, side theorem. Okay. Okay, so in this example, we are going to prove why triangle CDE is congruent to triangle EFD. And we also have the information that this line segment is going to be congruent to this line segment. And this line segment is parallel to this line segment. Okay, so let's start with the givens. Okay, so we have that line segment CE is congruent to line segment DF, and that's because it is given. Okay, and then we see that these two lines right here are parallel to one another. And if you look at this line and you think about in a plane, if you continue this parallel line that way, and it's always continuing in this direction and in this direction, and this parallel line, which continues in this direction, and this side of it continues in that direction, and this line right here, okay, it intersects both of those parallel lines. So we know from our theorems that an intersecting line that intersects two parallel lines in a plane at two different points is a transversal line. So we need that piece of information in order to deduce further information for this proof. So let's write that transversal line, okay? Because we're going to need that piece of information, like I said, to get another piece of information about angles. So we're going to say that line segment DE is transversal to both parallel lines, line segments, CD and EF. Okay, and then when you write the reason, you're going to say an intersecting line that intersects two parallel lines is a transversal. Okay, so we're going to say the intersecting line that intersects two parallel lines is called a transversal. Okay, so then moving on, like I said earlier, by knowing that this is a transversal line, we want to inherit further information from that in order to prove why certain angles are congruent, whether it's an interior angle, exterior angle, but we need to know that information in order to have another piece of evidence to prove why this triangle is congruent to this triangle. Okay, so we can say that this line segment is congruent, this angle is congruent to this angle because alternate interior angles of a transversal line are congruent. Okay, so we needed to say this statement and reason first in order to prove why this angle is congruent to this angle. So let's write that. For number 3, the reason, angle CEF, okay, and you have to make sure that the E is in the middle of that term right here of angle CEF to ensure that we're talking about this angle particularly right there, okay? All right, so angle CEF is congruent to angle FDE, okay? And again, we have to write a reason. So the reason here is going to be alternate interior angles of a transversal line are congruent, okay? So that's that one. All right, so we need one more piece of information in order to prove why the triangle CDE is congruent to triangle EFD. And so if you look right here, you can see that this line segment belongs to this triangle and this line segment belongs to this triangle. Okay, so it's the same line segment, which means it has the same distance to each other, the same distance for both this triangle and this triangle. So therefore, it's congruent, right? It's reflexive. This is a reflexive property where because this side belongs to this triangle, this side belongs to this triangle, it has the same measurement. And so we can say that this side of this triangle and this side of this triangle is congruent to each other. So we will say that line segment DE is congruent to line segment DE because of the reflexive property. Okay, and then with that said, we have enough information to prove why triangle CDE is congruent to EFD. Okay, so we can say that All right, let's just get some more room here.